Hey guys, Nagraj here, and welcome back once again to this series of learning C program. In the previous sessions, we saw that how to write a C program for swapping of two numbers without using third variable, and also we saw that how to write a C program to find the largest or smallest among three numbers using if else statement. In this session, we will be discussing about the next experiment, that is write a C program to calculate the roots of a quadratic equation using switch statement. And one more thing I would like to mention here, to write any code, any program, we have to follow some of the things here, that we have to understand the problem definition properly. Then only we can code it properly. So let me begin with the problem definition, that is here. Write in shortcut, write a program to calculate the roots of a quadratic equation using switch statement. So switch statement. So we have to understand first, before coding for this problem definition, we have to understand what is quadratic equation, what are the roots of quadratic equation, then how to use this switch statement, what is the construct, what is the syntax of using that switch statement, right? So here quadratic equation usually will be in the form of ax square plus bx plus c equal to 0. It will be there in this form. Usually quadratic equations will be there in this format, that in this form, that is ax square plus bx plus c equal to 0, and the quadratic equation is this one, x equal to minus b plus or minus then square root b square, just I am writing like this, b square minus 4ac, x equal to minus b plus or minus square root of b square minus 4ac whole divided by 2 into a. This is what quadratic equation is. From this we have to find the roots of this equation. So usually we use this b square minus 4ac to identify the quadratic equation, that this whatever, after calculating this, we are storing it in a variable d, and we are checking that whether these roots of this equation are equal or complex or distinct or real and imaginary, real and distinct or real and equal, that we are identifying with the help of this d equal to b square minus 4ac, that is d is nothing but discriminant. So that we are finding here, that is if in the case d equal to d less than 0, this d less than 0, then no roots are found. Then if d equal to 0, then roots are equal, that is roots are real and equal. Then d greater than 0, then two distinct roots, two distinct roots, that is complex, roots are complex, so that we are deciding based on the value of d. So this is about quadratic equation, and the switch statement have a syntax like this. Switch is used for handling multiple cases, so that is the reason we are using here switch statement. Switch expression in bracket, it will be having case, then here this is a constant expression, constant expression, then a number of statements we can have here, then we have to have break. This break is an optional statement which breaks the execution control from this case. This is the case is a keyword, this switch is also a keyword, and whatever the expression we are giving based on this expression, this constant expression will be get matched. If this expression is matching with this constant expression of case, then it will be executing these statements which are the statements which are belonging to this case, and after executing it will be breaking from that case and it will come out from the switch statement. This is how this switch statement works. And there is one more case present, constant, again constant expression, then again statements. Like this we can have n number of cases in switch statement. So this break is also a keyword, that is an optional statement we can have. If there is no cases matches with this expression, then the switch statement will be executing the default case, default case. Then here we can have a number of statements, then break this. If there is no case match with this expression, that assume that case 1 instead of this constant expression, what I'll take 1 here. And if expression is not equal to 1, then is not equal to some other value, then there is no matching expression, there is no matching case with this expression in this switch statement. It will be executing default statements if it is present. This is also default is also an optional statement in the switch. Then if it is present, it will be executing all the statements here and breaks the control of execution and come out from this switch statement. This is how this switch statement works. So we are making use of this switch statement to find the roots of a quadratic equation. So we'll code for this particular problem definition, and here we have header file, that is hash include stdio.h. This hash include is used to include the header files from the standard library. So this stdio.h is a header file. stdio.h stands for standard input output header. That file we are inheriting from the standard library. So we are having one more statement here we have to have, because of this problem definition we need to include that include math.h, because we are using some mathematical methods or functions here, that is such as square root. The square root method is present, square root function is present under this math.header file. So for that purpose we have to include this standard library. And as usual, main is the execution. Each program of C begins its execution from main method, and this integer is a return type of this main method. Then here we need to write our code for this finding the roots of or calculating the roots of a quadratic equation. So let me begin with coding for this finding the roots of quadratic equation. So what I'll do, I'll take int flag equal to 0. Initially it is 0, I'm initializing it to 0. I'll tell what is the reason I'm taking flag. Then float a comma b comma c comma d, because in quadratic equation we have a b c, that is b square minus 4ac. So for that is the, those are the coefficients of the equation. So those values we need to pass, those values we need to give. For that purpose, storing those coefficients, I'm using a b c variables, and d is a for discriminant. Then we have r1 here for real number, root 1 and root 2. Then real number and imaginary number. So for these we have these many variables. Then now what I'll do, I'll be asking from the standard input to enter by the user ABC coefficients. So enter coefficients of a equation, coefficients for equation. So for reading those three values, three coefficients, we have to use scanf. Scanf is a method to read, is a function to read the values which are entered by the user, that is %f. Because we have declared them as float type, we have to use float. You have to use %f specifier. So %f for b, %f for c. Then we have to read those values from the address of a comma address of b. This ampersand indicates that address of a b c. So from that location we need to read those three values. After reading, what we have to do, we have to identify, we have to check whether we have to check discriminant value. If for that purpose, what I'm doing, if a not equal to 0, if a not equal to 0, then what I have to do, this a is one among the coefficient. So if a is not equal to 0, then what I have to do, I have to find d equal to b into b minus 4 into a into c. Then after finding discriminant value, if d greater than 0, then what I have to do, I have to set flag equal to 1. Then else if d less than 0, what I have to do, I have to set flag equal to 2. I have to set flag equal to 2. Then else flag equal to 3. These are the three values: flag equal to 1, flag equal to 2, flag equal to 3. This is for switch case expression. switch expression. For that is the reason I am making use of flag variable. So after this what I'll do, I'll write switch case here to check whether d value is having a flag as 1 or flag as 0 or flag as 3. So switch flag, then that case 1 is what? Case 1. Then I'm using here printf statement. Printf, what I'm saying, the roots are real and distinct. The roots are real and distinct. Then r1 equal to the first root is minus b plus sqrt d divided by 2 into a 2 into a. This is my first root. Then second root is minus b minus sqrt of t, square root of t, that is a discriminant. Then divided by 2 into a. These are the two roots, real and distinct. Those roots are real but they are distinct. So then print them. After calculating, print r1 and r2. So for that we have to use printf. Then r1 equal to, because they are floating type, so what I'll do, 7.3f slash n, and r2 equal to percentage 7.3f, then r1 comma r2, that we are printing, and break the execution and come out from the switch case. If this flag is 1, if flag is equal to 1, this case will be get executing, and it is saying that it will be taking a b c values. It will be identifying the roots, these two roots, and it will be displaying here, and it will come out from that case. If flag is not equal to 1, it will never go to this case. So it will go and check for other cases. Case 2 is what? Printf. Then here we have roots are complex. That is nothing but roots are complex. That is nothing but roots are distinct. Both the roots are distinct. Then so print or calculate the real number and the imaginary number. Minus b divided by 2 into a. This is real number. Then imaginary number equal to sqrt, then minus d, because it is imaginary, minus d, 2 into a. 2 into a semicolon. Then print f, print the real and imaginary number. Print f r1 equal to percentage f 7.3 f, then slash n, pardon, uh, plus I plus imaginary number plus I percentage 7.3 f, then slash n for r2 equal to percentage 7.3 f minus I percentage f minus I percentage 7.3 f, then print have the variable here, that is real and image, that is imaginary number, comma real and image. Because we are displaying here, we are adding plus I plus minus I, that is real and imaginary, we are adding and subtracting from those real and imaginary number. Then after printing that, break it. So that is case 2. Then the next case is case equal to 3. Then print f the roots are real and equal, the roots are real and equal. Then calculate them, that is r1 equal to r2, that is equal to minus b divided by 2 into a 2 into a 2 into a. Then print them printf r1 equal to r2 colon percentage 7.3 f, then r1, because both the roots are same or equal. Then after printing, break it if this is the case matching with that regular expression. Then if that a is not equal to 0, these all things will happen. If it is equal to 0, if a equal to 0, then we have to go for else statement. Here printf then print the statement equation is linear. Equation is linear. So this is how it works. So we'll execute this program and check whether it gives the proper output or not. So click on the run button. Yeah, there is an error, r1 equal to, so let us check that. So error is expected semicolon before bracket token something like line number 50. Line number 50 is here. So here what is missing, bracket is closing. Okay, this bracket, we have to open this bracket. Okay, check it once again. Yes, we got it. Enter coefficients of equation. So what I'll do, I'll enter here some values for checking the roots of equation of quadratic equation. So a equal to 2.3, then b equal to 4.0, then c equal to 5.6, then hit the button enter. Roots are complex, and r1 equal to minus 0.870 plus imaginary is 1.296, and r2 is minus 0.70, then minus imaginary number is 1.296. So these roots are complex, and check it for different values. And so I'll run it once again and we'll give some different values and check the roots are complex or real and distinct and both are equal. So I'll run it once again and I'll pass some values: 5, 10, then 15. Roots are complex again. So this is how this quadratic equation gives us roots, and this is how we can write a C program for finding the roots of a quadratic equation. So if you are having any doubts in it, please do ask your queries, and thanks for watching.